All right, welcome to another video. In the next couple of videos, we are going to be looking at first order ordinary differential equations. We are going to be looking at the methods of solving first order linear differential equations. The first method we are going to be looking at is separation of variables, or as I like to call it, variables separable. Then secondly, we look at homogeneous equations. We are going to be looking at linear differential equations. We are going to take a look at the Bernoulli's equation. And then lastly, we take a look at exact differential equations. So these are all the methods of solving first order differential equations. Let us take a look at the first method. Welcome back. So we are going to be looking at separation of variables. Now, the method of separation of variables, what you try to do is that you try to take all the terms that have x's on one side of the equation and all the terms that have y's on one side of the equation. Then you integrate both sides of the equation to get your answer. Let us take a look at an example to y all over x. So the solution, what you aim to do is that you want to take all the terms that contain x's on one side, all the terms that contain y's on one side. Let us take a look at how that is done. So this is dy dx is equals to y all over x. Now I have y all over x here, I have dy all over dx here. If I multiply dx to each side, I will get the x coming here and the x disappearing from this side. Let us do that. Dot the x, dot the x. Now the x will cancel, the x cancels here, leaving us with what? Dy to be equal to, this will be y all over x times the x. Okay, now we are beginning to form something here. So how can we get rid of y? We need to bring y to this side, because remember we say we need to bring all terms that contain y to one side, all terms that contain x's on the other side. So what must we do here to eliminate y on this side and bring it to this side? That is right. If you can multiply this side by 1 over y, you multiply this side by 1 over y. Now you can see this y will take out this one and leaving you with 1 over x times dx. Okay, so this will imply that 1 all over y dy is equal to 1 all over x dx. Now all of a sudden we have x's on one side and all of a sudden we have y's on the other side. So what's the next step? You integrate both sides. So if I integrate this side, I integrate this side. Now what is the integral of 1 all over y? That would be the natural log of y plus c. So this is equal to ln. Now I'm going to put absolute values because you cannot have negative values in the absolute value function, or it gives you an undefined function. So it will be ln of y plus, I'll call this c1, is equal to the integral of 1 over x is what? Ln of x. So this will be ln of the absolute value of x plus c2. Okay, now let's take c1 to this side. This will mean that ln of y will be equal to ln of x plus c2 minus c1. Now c2 and c1 are all constant, and a constant minus a constant will give you another constant. Take 5 for example. 5 is a constant, 3 is also a constant. If you take 3 away from 5, you get 2, but 2 is also a constant. So c2 minus c1 will give you another constant, and let's call that constant c. Let's say c2 minus c1 is another constant c. So we can say that ln of y will be equal to ln of x plus c. So in the other coming videos, or what we are going to be doing for now, I wouldn't be going through this process again. I will just put c on the right hand side. Do you understand? I'll just put c on the right hand side. I will not go through this process of explaining why c2 minus c1 is equal to c. Now I'm looking for y, not ln of y. How can I get rid of this natural log on the left hand side? If I take e on both sides, that is the exponential function. If I take e on both sides, I will eliminate the natural log. So let's take e on both sides. If we take e on this side, we take e on this side. Remember, this e will be raised to everything here. Now e will get rid of the natural log, leaving you with y to be equal to. Now remember from your laws of indices that when you have let's say m to the n plus 2, this means that this is equal to m to the n times m to the 2 from your laws of indices. So we are going to apply this knowledge right here. So this will be equal to e to the ln of x times e to the c. Okay, let us make some room up here so that we can continue. Implies that y is equal to this implies that y is equal to e to the ln of x times e to the c. Now I want you to do something for me. Take your calculator, punch 10 raised to the power of log 10 of a number like this. That 10 raised to the power of log. Now on your calculator, automatically it will be in log 10. So just put a number here, but let me just put the 10, then put 5 here. Now what will happen is that your answer will be 5. So anytime this matches this, it takes out the whole of this, leaving you with the number here. You can try it for any number and you get exactly what is here. As far as it is 10 raised to log of 10 to this, it will give you what is here. Now the same thing for ln's. If you have e to the ln, now e to the ln of anything, let's say x, this e will cancel this, giving you with x. Why? Because ln is something as log to the base e of x. If we put x here, so ln means log to base e, and if we have something like this, because of this matches this, it will take out this, leaving you with only x. So with that knowledge, e here will cancel ln, so we are going to get that y is equal to what is left? It will be x times e to the c. Now e, if you punch e on your calculator, you get some numbers that don't terminate. E is also a constant, c is also a constant, so we can replace this term by another constant, because e to a constant, e itself is a constant, c is a constant. Now a constant raised to a constant is still a constant, so we can replace this with, say, a. You can choose b if you want to, but for the purpose of this video, let me just say a. So this whole thing here is equals to a. Now we can write our function y. Now let us, because y is the dependent variable, I'm going to put x, showing that x is the independent variable, to give me what? Now x times a, because we replace e to the c with a, this will be just a x. This is the solution to this equation. The equation was the y, the x is equals to y all over x. This is the solution. This is the solution to these differential equations. Y as a function of x is equals to a times x. A is just a constant, x is a variable, the independent variable. So as you can see, we said earlier that when you solve a differential equation, you get a function that relates the dependent variable to the independent variable. You can see this is the dependent variable, this is the independent variable. So this is a function. Okay, now I want to bring something to your notice. Now this type of solution is called a general solution. This is a general solution to this equation. Why is it the general solution? Now it is the general solution because the value of a is unknown. I can put a to be 5, I can put a to be 2, I can take a to be anything. Now because we don't know the exact value of a, we say this is a general solution. If the exact value of a was known, then we are going to have a particular solution. The value of a was known, we have a particular solution. If the value of a is not known, we have a general solution. In the next video, in the next example, we'll take a look at the general solution and particular solution. For this equation, this is its solution. So welcome to another example. This is another example on separation of variables. Now in this case we have initial conditions. This y of 1 is equals to 1 is our initial condition. We are going to use it to obtain the particular solution after finding the general solution. This is our question. It says dy dx is equals to y plus 2 into x plus 1. Let us solve this. Solution. So dy dx is equals to y plus 2 into x plus 1. We have y plus 2, we have x plus 1. Remember, what we are trying to do is to get all y's on one side of the equation and all x's on one side of the equation. Now, I must warn you, please don't ever try to take dy to the other side, because if you try to take dy to the other side, you end up with something like 1 all over dy. And I'm very sure you've not seen something like, because when you have to integrate this now, I'm very sure you've never integrated something like this. The integral of y with respect to 1 over dy. This is a crime. Don't do it. So this is ruled out. Don't ever take dy on the other side. Always ensure that you take the ones that have y on the other side, and this dx takes to the other side, so that you don't have any of the dy's or the dx in fractional form, because that will not work out for you. Let's clean that very fast. Let's clean that very fast. Okay, so we can take the whole of this term, because it is multiplying this. We can take the whole of this term to this side. How do we do that? If you multiply each side, let's just put bracket to tell that we are multiplying each side. You multiply each side by 1 all over y plus 2. It will cancel out this. It will appear on the other side. So this will imply 1 all over y plus 2 dy dx, which will be equal to what? What is left here? X plus 1. This will take out this. Let's put that into bracket. We want the x on this side. What must we do? If I multiply both sides by the x, it will cancel here. It will appear here. So this will be 1 all over y plus 2 dy is equal to what? This is equal to x plus 1 dx. All right, we have x's on one side, we have y's on one side. What's the next step? Integrate both sides. If you integrate this side with respect to x, you integrate this side with respect to y. Now this is the integral of 1 over y plus 2. Now y plus 2 is a linear function, and when you have 1 all over the linear function, the integral is something ln of whatever is here, y plus 2, divided by the derivative of this. Now if we differentiate this with respect to y, differentiate y plus 2 with respect to y, the only thing you get is 1. If we divide this thing by 1, it won't change the value. Okay, now I won't put the c here. I'll put the c on this other side. So this will be equal to, now the integral, we can integrate each term, because this is x plus 1. We can take the integral of x with respect to x. We can take the integral of 1 with respect to x. Now the integral of x with respect to x, we will have x squared divided by 2. The integral of 1 will just be x. With respect to x is x. Now we'll put our constant of integration plus c. We are looking for y, not ln of y plus 2. What can we do? We take the exponential function of both sides. We take e of both sides. This, everything is raised like this. So e will cancel this, leaving us with what? Y plus 2. This is equal to, now we can apply our laws of indices. So this will be e to the x to the 2 divided by 2 times e to the x times e to the c. We are going to replace e, because e is a constant, c is a constant. So we replace e to the c with, so this will be replaced with e. Okay, so y is equal to, we can take this 2 to the other side. Now a multiply this, you're going to get, this is a times e. Let's put this thing together. Let's put this 2. This is e to the x squared divided by 2 times e to the x. You can just put it as e to the x squared divided by 2 plus x. Now the 2 that was here minus 2. All right, this right here is called the general solution. Y is the general solution to this equation because the value of A, the value of the arbitrary constant is unknown. We don't know the value of this constant, so we call this the general solution. But we have been given initial conditions. Anytime you are given initial conditions, what they're asking from you is not the general solution. They want you to find the particular solution. So let us find the particular solution. Now they've told you that when x is 1, y is 1. So we are going to replace y with 1, x with 1. If we do that, because we want to look for the value of A now. So we've been given that y of 1 is equals to 1, which means that when x is 1, y is 1. So this will be equal to A times E. This is x squared divided by 2. 1 to the second power is just 1. You divide it by 2 plus 1 minus 2. Okay, we can take minus 2 to this side, leaving you with 1 minus 1 plus 2 is 3, which is equal to A times E. Now a half plus 1 is 3 all over 2. Let's find the value of A. It means that the value of A is equal to 3 divided E to the 3 all over 2. Now, this is the value of A. We are going to take the value of A and plug it back into the general solution to obtain the particular solution. Let us make some room up so we can do this. All right, so this is the general solution, but we've been able to find the value of A from what we did last. So we are going to take the value of A and plug it back into this equation to obtain the particular solution. So y is equal to A times this, but A is this. So we are going to replace this with this will be 3 divided by E to the 3 all over 2 into E to the x squared divided by 2 plus x. Now everything here put in bracket minus 2. This right here is the particular solution. This is a particular solution to this differential equation. This is the general solution. This is a particular solution. You can see the differences between the general solution and the particular solution. The general solution will always have arbitrary constant. The presence of arbitrary constant in the solution will tell you whether it is a general solution or it is a particular solution. You can see A is the arbitrary constant. It appears here, so this makes this the general solution. There is no A here. There is no arbitrary constant here, which tells us that this is the particular solution. Welcome to another example. So in this example, we are going to be looking at a trig function. So this is cos square x, dy dx is equals to y plus 3. Let us solve this. You can see we have no initial condition, so what we are looking for here is just the general solution. So solution cos square x dy dx is equals to y plus 3. What's the first step? What's the first thing to do? The first thing to do is to make sure that you take all your y's to one side and you bring all your x's to the right hand side. But in this case, you cannot only take y to this side without disrupting this equation, because if you say you want to take y to this side by negating y on both sides, it will have dy dx, this whole term minus y, and it will be very impossible for you to integrate it. So what do? You take the whole of this term to this side. Okay, but before we do that, let us take cos square x to this side first. So if I multiply each side by 1 all over cos square x, I will have 1 over cos square x here. It will cancel out this, because 1 over cos square x times cos square x is 1. So I'm going to have that dy dx is equals to y plus 3 times this, you have cos square x. All right, now we can take y plus 3 to this side. How can we do that? If I multiply each side of this equation by 1 all over y plus 3, it will cancel here, it will appear here. So this will imply 1 all over y plus 3 dy dx to be equal to 1 all over cos square x. Okay, multiply the x to each side. If I multiply the x on both sides, it will cancel here, it will appear here. Multiply the x on both sides. I'm going to have that this is 1 all over y plus 3 dy is equals to, now 1 all over cos square x. Recall that 1 all over cos x is secant x. So 1 all over cos square x is what? Secant square x. So this is sec square x times dx. Okay, we have all y's on one side, we have all x's on one side. What's the next step? Integrate. So integrate both sides. Now, we did something like this earlier. This will just be the ln of y plus 3, because this is a linear function, divided by the derivative of y plus 3, which is 1. So this will be equal to, now, see the integral of secant square x. Now recall that if you differentiate tan x, you get secant square x. So the integral of secant square x is tan x plus c. Tan x plus c. Okay, we are looking for y, not ln of y plus 3. What do? That's right. Take the e of both sides. If I take e here, I take e here. I'm going to get that y plus 3 is equal to, this means e to the tan x times e to the c, from your laws of logarithms. Sorry, from your laws of indices, I meant to say. Now we can take 3 to this side. This implies that y is equals to e to the tan x. Now e to the c is constant. Let's call it a. Now it is multiplying by a, so we put that a here. Okay, now this 3 we are taking to this side, so this will be minus 3. This is the solution to this differential equation, and as you can see, this right here is the general solution. Why? Because we have the presence of an arbitrary constant. That will be for this question. We are back with another example. Sin x divided by 1 plus y dy dx is equal to cos x. Let's get it done. So solution, this will be sin x over 1 plus y dy dx is equal to cos x. Well, the first thing to do, make sure you have x's on one side, all the terms that contains x's on one side, all the terms that contain y on the other side. Now in this case, if I multiply each side by 1 all over sine x, 1 over sine x times sine x over 1 plus y, it will cancel this. So you are only going to be left with, this will equal 1 over 1 plus y dy dx, which is equal to what? Cos x times 1 over sine x. We leave you with cos x all over what? Sine x. We have dx here. Let's take it to the other side. Multiply each side by dx. 1 over 1 plus y times dy dx times dx. It will cancel it. So you're going to be left with 1 all over 1 plus y dy, which will equal to what? Cos x. This is cos x all over sine x dx. Okay, we've successfully isolated all x's on the other side and all y's on this side. The next thing to do is to integrate both sides with respect to the variables. So this is with respect to x, integration with respect to x, integration with respect to y. Now we've done something like this before too. This is a linear function of y. So if you integrate this, you are going to get this will just be the ln of 1 plus y divided by the derivative of 1 plus y. But the derivative of 1 plus y is 1. So even if we divide by 1, it's not change the value. This will be equal to, now let's take this with baby steps. The integral of cos x all over sine x dx. Okay, now I'm interested to solve this integral because it is looking complicated, but it is actually very easy. So let us consider this integral. So the integral of cos x all over sine of x dx. Now I'm going to let my u to be equal to sine x. Let u equal sine x. So du dx is equal to what? If I differentiate sine x, what do I get? I get cos x. Dx is equal to cos x, but I want to make the x the subject of the formula here. So what I will do is that I will say that du is equals to cos x dx. If I divide both sides by cos x, divide this one by cos x, I'm going to get that my dx is equals to du all over cos x. Now I'm going to replace the x with the x with this, and I will replace my sine x with u. Let's do that. So this, I put this in the bracket, to differentiate it from my real work here. So this will be equal to the integral of cos x all over sine x. But I said sine x to be u, divided by u. What is dx? Dx is du all over cos x times du all over cos x. Cos x, 1 over cos x. They cancel out, leaving us with what? The integral of 1 all over u du. What do we know about this integral? It will give us ln of u plus c. So this is equal to ln of u. But what is u? U is equal to sine x. So this is sine x plus c. And this is the this integral. We've solved this integral. So all we need to do is to replace this with the right hand side. Let us make some room up so we can do that. So ln of 1 plus y is equal to the integral of cos x over sine x dx, but we found the solution to be ln of sine of x plus c. So we can say this is ln of sine x plus c. We are looking for y, not ln of 1 plus y. What do? We take e of both sides. This will take care of this, leaving us with 1 plus y to be equal to. We apply our laws of indices. This will be e to the ln of sine x, but e to the ln of sine x times e to the c. But e to the c is just another constant. We can call it a. And say let it be equal to a. So what do we do next? This will take care of this ln, leaving us with 1 plus y to be equal to, we are left with sine of x here times a. Put the a here. All right, what do we need to do next? We need to take 1 to this side, so y as a function of x. Now if you want, you can just erase it. I'm just trying to be professional. So y is equals to a sine x minus 1. This is the solution to this differential equation. This is the solution. What type of solution is this? This is the general solution. Why? There is an arbitrary constant a in the solution. Welcome to the last example we are going to do under separation of variables. Let us get into the solution. So we have dy dx to be equal to xy minus y. So how can we separate x's and y's? How can we separate y from x? We can have x would, because we have xy minus y. What do we do? Notice that if we factor out y, we can have y into x minus 1. Let's do that. So the y dx is equal to, let's take y outside. You are going to get x minus 1, because y times x will give you xy. 1 times negative 1 will give you negative y. Now what do we do here? Let's take y to this side by multiplying both sides by 1 all over y. What we get here, we're going to get 1 all over y dy dx to be equal to x minus 1. What do we do next? Let's take dx to this side. I'm going to multiply each side by dx, so that I will have 1 all over y dy to be equal to x minus 1 dx. Put this into brackets. Oh, all of a sudden we have all y's on this side, all x's on this side. So what do we do next? We integrate the integral with respect to y. Now the integral of 1 over y, as we know it, is what? Ln of y. So we have ln of y is equal to, this is x minus 1. We are going to integrate term by term. So we integrate x with respect to x. We are going to integrate negative 1 with respect to x. Now the integral of x is what? X squared divided by 2. The integral of negative 1 is negative x. Don't forget your constant of integration. My teacher used to say, anything without your c is 0 plus c. Okay, now we are looking for y, not ln of y. What do? We take e of both sides. Now e is raised to this whole thing, so e will cancel this, giving us with y to be equal to e to the x squared divided by 2 minus x plus c. We can apply our laws of indices, which will be e to the x squared divided by 2 times this is negating x, so this will be e to the x, like this, times e to the c, times e to the c. Now e to the c is just another constant. We can replace that with b. Let's say b this time. So this right here, we can call it b, where b is also a constant. So y is equal to, now e to the c is multiplying this, but e to the c is equal to b. So say that this is b times e to the x squared divided by 2 all over e to the x. Okay, looks like we're having some clashing here. I say this is clashing with this, but this is our answer to this ODE. Let us write it. Okay, so let us write this up here. So y, my marker is almost finishing. Y is equal to b, which is the arbitrary constant, times e to the x squared divided by 2 divided by e to the x. This is the general solution to this differential equation. Now God said, go into the world and multiply. I say, go into the world and explore. Solve more examples on separation of variables and become very good at it. See you in the next video.